Okay, so today's lesson is over functions. What you're going to do today is identify. So your only answer is going to be yes, this is a function, or no, this is not a function. In order for you to understand this lesson, you need to know what a function is. A function is a relation where every input has exactly one output. So it's like if you go to a restaurant and you put a quarter in those little toy machines, you're going to get one toy back. So the input would be your quarter and the output would be your toy. So in math though, we use numbers. Those are our inputs and our outputs. So basically what I'm going to do today is teach you how to identify a function. At the top, these are going to be examples of functions, and at the bottom, these are going to be examples of what a function does not look like. And so there's 4 types of things that you'll be able to look at. The first is called an ordered pair. An ordered pair, you know that you have an X and a Y. So for example, if I have the ordered pair 2, 3, then that means I have an X of 2 and a Y of 3. Okay, and then the next one, let's say I have a 1, 4 and a 3, 5. Okay, the reason that this is in the section titled function is that for every input, I only have one output. And what does that really mean? Your inputs are your X's. So if you want to look right up here, our inputs are our X's and my outputs are my Y's. So basically the simple trick to doing this is to only look at the X's. So basically you're just gonna say, okay, if this input is a 2 and this input is a 1 and this input's a 3 and they're all different, then this is considered a function because my input of 2 has an output of 3 and nothing else is repeating that. Now, if I had a function with a 2 and a comma like 5, then that would be an input having 2 different outputs, and you can't have that. Remember, it's every input has only one output. So how could I make this not a function? So that's what I'm going to show you down here at the bottom. So I'm going to do ordered pairs. And this time I'm going to use the exact same ordered pair of a 2, 3. And let's just use the same thing, 1, 4. Oops. And then this one, 3, 5. Now to make this not a function, I'm going to add another ordered pair. And what's going to happen is, let's say I have an input again of 2, and this time my output is 4. Why is this not a function? Because I have 2 inputs of 2 and they have different outputs. So again, the cheating way, the easy way, like the shortcut way of doing this is basically look at your inputs, your X's, and if none of them repeat themselves, it's a function. So here I have an X of 2, an X of 1, and X of 3. Because they're all different, it's a function. Here I have an X of 2, 1, 3, and 2. Since these 2 repeat themselves, then it's not a function. Now you don't care about the Y's. These Y's could all be the same number and you're not going to care about those. Okay, same thing in a table. Remember that a table is just a bunch of ordered pairs. I could literally take these same numbers and put them in an XY table. I could have 2, 3, 1, 4, and 3, 5. And why is that a function? Because every input has only one output, meaning all the X's are different numbers and they don't repeat themselves. If you want to see another one, so I could have 1, 2, 3, and I could have every output over here being 4, and this is still in the function column because we really don't care about the outputs. We only care that every input has only one output. So basically what I teach my students to do is cover those outputs up, cover those Y's up. If all the X's are different, it is a function. So let's go down to the bottom to table and let's make it not a function. So I'm going to have my XY column. If I want to use this one, I have a 2 and a 3, a 1 and a 4, a 3 and a 5, and I could make this not a function by choosing something and repeating it in the X column. So like I could choose 1 and put like 6. So here I have a 1, 4, and here I have a 1, 6, and they cannot repeat themselves. Let's do one more, just so you guys can see. If I have 2, 2, 2, and 3, 4, 5 over here. Remember up here, the Y's can repeat themselves, but the X's cannot. For every input, you can have only one output. Okay, that's ordered pairs and tables. Now let's look at mapping diagrams. Mapping diagrams is just a fancy way of making ordered pairs. So it's kind of like another way of doing a table or ordered pairs. Basically, you'll have two ovals, and over in the left are your X's and over in the right are your Y's. So let's say I have a 1 and a 2 over here, and let's say I have a 5 over here. And here we're pointing. So basically, this is called a mapping diagram, and this is a function because if I was to write these as ordered pairs, I would write the X is 1 when the Y is 5, and the X is 2 when the Y is 5. Why is this a function? Because I only look at the X's, because every input has exactly one output, meaning when my input is 1, my output is 5. When my input is 2, my output is 5. Again, I can just cover those up and look to make sure my X's don't repeat themselves. So how would I make it not a function? I could have had a 1 and a 2, and let's say I had a 5 and an 8, and I had this going on. Why is this not a function? Well, if I was to write these as ordered pairs, again, that's my X, that's my Y, this would be 1, 5, and I'd also have 1, 8, and I'd have 2, 8. And that is not a function because, again, if you cover those outputs up, I have 2 inputs that repeat themselves, and you cannot have that. So this right here makes it not a function. Okay, the last type of thing you'll have to be identify as a function is graphs. Graphs is a little bit different because you can do this thing called the vertical line test, and it makes it so much easier. Yes, with a graph, you could go write some ordered pairs, but that takes a lot of time. So I'm gonna draw 2 graphs for you. Okay, remember that in my graphs, this is my x-axis and that's my y-axis. And I'm gonna grab a different color so you guys can see. The x and the y-axis aren't really part of the picture, it's just your coordinate grid. Okay, so I'm gonna make this a function. Now, the cool thing is functions can be curved lines. So basically, to tell if this is a function, you perform what's called a vertical line test. You take a pencil or a pen and you draw a vertical line. Vertical means straight up and down. If your vertical line only touches the picture one time, it's a function. So I'm gonna draw a vertical line right here. See my red picture? It only touched one time. So that is good, that means it's a function. You could draw another vertical line and each vertical line can only touch one time. Since it only touched my red picture once, that's a function. Okay, I'm gonna do another one. Would this be a function? Well, if I draw a vertical line, it touched once, it touched once. And your picture can literally be anything. It could be dots, it could be anything. As long as your vertical line only touches the picture once, it's a function. So let's look at what would not be a function. So here I have my x and my y-axis, my x and my y-axis. So I'm just gonna draw a circle. Why would this be considered not a function? Well, because if I draw a vertical line, meaning straight up and down, how many times did that vertical line touch my picture? It touched it 2 times. So that's not a function. Okay, well, what if my picture is dots and I have these dots like kind of randomly all over the place like this? Well, you would just draw a vertical line. That one's good because it only touched one dot. That one's good. That one's good. But what happened right here in this vertical line is it touched twice, and it cannot touch more than once. So that makes it not a function. So again, just a quick recap. Today's lesson, you are telling me yes, it's a function, or no, it's not. It's that simple. Again, up here you have your examples of functions. At the bottom, you have your example of not a functions. If you want to pause this video, you can take a picture of the screen so you have something to refer to when you do your assignment. Okay? If you have any questions, shoot me or Mrs. Payton an email.